Hi, welcome to my channel. In this video, I am going to explain about the linear regression.
Simple linear regression model. This is the one of the supervised learning algorithm. Okay, supervised learning algorithm. What is meaning of regression? Okay, regression nothing but you are going to predict the new value based on the existing data. Okay, for example, here the output here in this data set, gender and height are nothing but your independent variables. And weight is nothing but your dependent variable or target variable. Okay, now here the target variable or dependent variable in the form, the values of the target variable and the variable in the form of a continuous values. So at that time you are going to apply technique called as a regression technique. Now here in our data set we are applying the linear regression. What is meaning of regression? What is the simple line equation? Y equal to mx plus c. Y equal to mx plus c. X is nothing but your variable, that is a height variable, and y equal to weight variable. So simply weight equal to height into corresponding m value plus corresponding c value. Okay, y equal to mx plus c. You can write this like this as y equal to mx plus c. Here m is nothing, x is nothing but a independent variable, m is nothing but a slope, and this is nothing but a coefficient that can connect the line. Okay, so here y equal to mx plus c. This is converted into our equation like weight equal to theta 1 into height plus theta naught. Okay, so theta naught and theta 1 are nothing but your hyperparameters. Okay, hyperparameters. Now we are going to develop a model. That model is called as a simple linear regression model. So the relationship between the independent variable and dependent variable is y equal to mx plus c. So here that is weight equal to theta naught plus theta 1 into height value. Now here if you draw the graph, if you draw the scatter plot between the height versus weight, so the data points scattered from the different locations. So based on the our equation y equal to mx plus c or weight equal to theta 1 and theta 1 into height plus corresponding to theta naught value. Okay, there are different possible lines that fit for the our data set. This is a one line that fit for that is go through the line our data set. Okay, and this is also one line that is also goes through the on data set. There are different lines are there that passes through our model, but these models are not fit for the our data set. Okay, so here by adjusting the values of theta naught and theta 1 value, that means y equal to mx plus c, by adjusting the values of m and c value, we are going to be fit a line. We are going to be draw a line that exactly fit for the our entire data set. Like that you have to draw this. Suppose this is a line 4, and this is a, for example, this is a line 1, and this is a model 1. Okay, this is a model line 3. Okay, line 2, like that. There we can draw a number of lines, but no model gives the better results. But the line L4 is exactly fit for the our data set. Okay, so this is the model. By adjusting values of theta naught and theta 1 value, we get the best line for the entire data set. Okay, this line L1 also having the theta naught and theta 1 value. L2 also contains the theta naught and theta 1, and L3 also contains the theta naught and theta 1 value. L4 also contains the theta naught and theta 1 value, but the values of theta naught and theta 1 are different for the different lines. Okay, by adjusting these lines, these values, you are getting the model, the line that exactly fit for the entire data set. This is the very important. Okay. Now here there is a, for example, here our model is fit. This is called as a model. This is called as a model. This model is fit for the entire data set. Now we are going to find out the error between the actual point versus predicted point. This line is called as a predicted line. This line is called as a predicted line, predicted point. Okay, what are the points that lies on the this line is called as a predicted points, and what are the data points above the line or below line are all called as a actual points. These are called as a actual points, actual points. Okay, now the predicted line, the predicted points lies on the our line equation. Okay, so for example, for this 60th for example the 60th point, where this is the height value, this is the original, this is the actual, this is called as the actual value. Okay, for example here. Now but what happened, your for this point where the weight value, for this point where the weight value, for this where the weight value, for example 61, for this 61 the weight value, actual weight value is say 8, for example. For example, the actual weight equal to 78. Okay, but what happened? Our model is predict the point as a 110. Okay, this is called the actual weight value. This is actual weight value, and we are getting the output as a 110. So there is some difference between the actual weight value and the corresponding predicted output value. This is called as the difference. This is called as a error. Okay, and sometimes the predicted point lies below the, suppose here for example this for this point. Okay, for this point the actual value is 175. This is called as the actual point. Okay, this is for y actual point is 175, but we are predict as a, for example we are predict as a 130. There is some difference is there. There is some difference. So this difference is 45, and this difference is 110 plus nearly 32. Okay, so like that we are getting some errors. So our aim is you have to minimize those errors. You have to minimize those errors such that you have to develop a line. So by adjusting the line equation, okay, by adjusting the theta and theta values, the theta naught and theta 1. So this is called as simply linear regression model. Okay, our aim is to minimize the error between the okay, predicted value versus actual value. Okay, this is called as a error. Okay, loss function. Now in order to how can you know which values will be makes your model perfect best model? That is what are the best value for the theta naught and the theta 1? How can you know these values? So in order to perform this one, we are going to define using the utility function that measures how good the model is, and or we can use we can define the cost function that measure how bad it is. That means based on the error values, we are going to measure find out the theta values. Okay, in the linear regression problem, people try to use the cost function as the cost function to measure that distance between the linear models predictions, and this is called as a predicted value. That means the points lies on the model is called as a predicted points, and the actual points above the line or below the line, those are called as a training examples. So the distance between the actual point and the predicted point must be minimized. The distance between the actual points and the predicted point must be minimized. Okay, this is called as error. This error must be minimized such that you have to find out the model. So that is about the linear regression. Okay, Now here, first of all, we are going to train on our training data set. Then we are going to apply the same model on the test data set. Okay. Now here, the first of all, we are going to we are going to fit the model. Fit is nothing but the training the model with x train and y train value. X train and y train value. So then after training the model, then we are going to fit with your corresponding x test value. Okay. Then we are going to predict the new values. Simply this is called as a linear regression. Now here we are having the different types of performance measures are there. The first one is called as a mean squared error. Okay, mean absolute error and mean squared error. Like that we are having the different types of performance measures are there. So the first measure is mean absolute error. Mean absolute error nothing but that suppose this one point is there. This is called x1 y1 and one more point is there, that is x2 y2. Okay, that means the actual point and this is called as a predicted point. The actual distance between the yi minus y is called as a y cap is called as a mean absolute value. Find out the sum of the average of all the predicted points and the actual points is called as a mean absolute error. Okay. And one more definition, one more technique is that is called as a mean squared error. The mean squared error is nothing but the sum of average of the all the actual value minus sum of the predicted value square of the mean square, the average of the sum of the elements sigma of I equal to 1 to n yi minus y cap square. This is called as a mean squared error. Okay. So like that there are different like root mean square error, like root mean square error. Just wait now. We are having the different techniques are there, like one like mean square error. Root mean square is there. Root mean square and r square value, adjusted r square value, adjusted r square value. Like that we are having the different types of performance measures are there to predict the performance of the linear regression model. Okay, so our aim is we have to minimize the distance between the actual value and the predicted value. That is the main aim of this model. Now I'm going to see one example program. Okay, that is a linear regression model. So here we are having the original data set contains 10,000 rows are there, 10,000 rows and 3 columns are there. So 3 columns are nothing but gender, height and weight. So here the weight values are in the form of a continuous values. Okay, and height is there, height also in the form of a continuous values, but we are not considering about the gender like male or female. We are simply ignoring the gender column, and based on the independent variable height value, we are going to analyze the height value. Okay, now weight value. This is called as a target variable. Okay, this is called as a independent variable. Now this target variable or dependent variable depends on the independent variable. Now we are going to establish a model f equal to x2 y. Y is nothing but a height, h is nothing but a height, and y is nothing but a weight value. Okay, or we are going to establish a model y equal to height versus weight. Now whenever giving the height value, our model is going to predict the corresponding weight value. This is called as a predicted weight. Okay. So now we are going to see that with some example with Google Color. Okay. So here I already placed that corresponding height versus weight .csv file in my Google Color. Okay. So here I am going to connect with Google Colab. connecting now. It is connecting with Google Colab. Okay, it's connected. It's connected. Now I'm connected with my Google Drive to access my data set. So the data set name is height versus weight.csv file that I already placed in my Google Drive. Okay, that is permanently stored in the Google Drive. Okay, so whenever you require, you can just simply access that data set by using the Google Colab. Okay, so now here in order to perform the simple linear regression model, where there are different steps are there. Okay, there are different steps are there. We'll see one by one. Okay, now what's our problem? The problem statement is here. Here we are going to be predict the height, predict the new weight value based on the height value. Okay, so that means there we are going to be establish a relationship between the height versus weight value. So based on the simple linear regression. So now that is called as a business problem. And the second step is identify the data set. So here the data set is according to our problem statement, we are select the more data set is like a height versus height hyphen weight dot csv. Now we are going to be load the first of all we are going to be mount the data set into. We are going to be mount the our Google Drive Google Colab with our drive, and then we are going to be select our file. Our file in our Google Drive weight hyphen height.csv. Okay, now we are going to connect with that file. Now we are going to import all the library files that are required for to perform the different actions like data pre-processing or whatever. Okay, so first of all we are importing the NumPy, Pandas, Matplotlib like that. So these files are going to be used for to perform the normal mathematical operations or visualization of our data set. So now, so in the file path contains the weight versus or height.csv file. Now we are going to read the data set pd.read_csv file that is stored in the data set. Now if you display the data set, now you are going to get it displays our data set. It displays the top 5 rows and the bottom 5 rows. Okay, so here the gender, the data set contains gender, height and weight. Okay, so how many rows are there? It contains the size of the data set is 1000 rows and 3 columns. Now in this suppose like 5 rows, then I am using the data dot. It displays the top 5 rows. Okay, now the next step is I am going to check whether the data set contains any missing values or not. So for that there is a simple command is there that is called as a data dot is null dot sum. That means it identify it check all the columns. If any columns contains NaN, okay, that will display a count here. Okay, suppose here the gender column is there, height columns are there, weight columns are there. So no column does not contain any NaN. That means here all columns are filled with some data. Okay, and then the shape of the data set is dataset dot shape that gives the 1000 rows and 3 columns. Now we are going to be draw the graph between scatter plot between the x-axis height versus weight. So now we are taking the x variable as a dataset dot allocation, that is all rows column 1 nothing but your height value dot values, and y1 equal to dataset dot allocation all the rows. The column means all the rows. The 2 means the last column is nothing but a weight value. Okay, dot values. Now plot dot scatter plot. The type of plot is scatter plot between the x1 and y1. The labels are height and okay, and color, the type of color is display color is orange. The size of the data points are 50, and the x labels are the type. The label of x label is height. The okay, the label of the y is weight. Now enter the entire plotting graph of the name is plot dot title equal to height versus weight. Now we are going to legend the things. That means we are going to display the legend on the lower right. Now we are going to display the plot dot, so it will display the scatter plot of the entire data set. The scatter plot of the entire data set. Now here I'm going to divide these points like x and y. X is nothing but a data set dot allocation. Okay, for all the variables, all the rows, and the last column. Okay, that means the height value. One is nothing but a height value values and in the corresponding x value. So it displays all the height values, and we are going to be and y equal to data set dot allocation all the rows and second column. That means all the weight values. Okay, it displays all the weight values. Now this is nothing but x values, x nothing but your height value, and y nothing but a weight value. Now that means our data set divided into two parts. One is features and corresponding class labels. Okay, here x nothing but a feature value and independent variable, y nothing but a dependent variable. Now we are going to be split the data into four parts. Okay, that is called as a training contains two parts and testing contains two parts. For that there is a method called as a from sklearn dot model selection. We are importing the train underscore test underscore split method is there, split class is there. Okay, split method is there. Now that based on that split method, we are going to split the entire data into four parts. That is train, x test, y train, y test, okay, equal to train underscore test underscore split. Now we are having the x nothing but your independent variable, y nothing but your target variable or dependent variable, that is a weight. Okay, test size equal to 0.2. That means out of 100 percentage, 20 is going for the testing purpose, and remaining 80% is for the training purpose. That means the entire data is going to 80% for the training and 20% for the testing. And random state equal to randomly we are assigning all the data into training purpose and testing purpose. Okay, and then we are going to the next step is building the model. The building the model means our model is linear regression. That model is present in the from sklearn to linear model. The linear model, okay, contains the linear regression. So we are in linear regression from the sklearn to linear regression model. Now our model, we are creating variable that is called as model. What is our model now? Linear regression. Okay. Now for this model, the model is building. Model is builder. Okay. Then we are going to be train this model with training data and that means x train and y train. X train and y train. So model dot fit function that fit the x train and y train. Okay. Now the model is training on the x train data and y train data. That means it establishes the relationship between the in height value and corresponding weight value. Then we are going to be test the model or predict the value. Okay, so for that model dot, that means we are going to create one variable that is called as a y predicted value equal to model dot predict of x test data. Okay, so here we are providing the only x test data. Based on the x test data, we are going to be predict the y value. Okay, now we this is called your predicted value, but actually we are having the actual y values also there. Okay, that is called a y test value. Now we are comparing the y predicted value and x test value. Okay, now we are going to be visualize the our entire data set. We are going to be visualize the entire data set. So here plot dot scatter plot between the x train and the y train, that means pink color. Okay, the color that is pink color, and we are going to draw the plot between the x train and model dot to predict the corresponding x train value. We are going to be predict the y value based on the x train value. Okay, so that color is equal to blue line. Okay, blue line, and we are going to draw the title of the graph is height versus weight based on the training set. Now x label is nothing but a height, y label is nothing but a weight. We are going to draw the graph that show that graph. So here it display the things like this one. Okay, this is called as the graph between the training data and the corresponding y label. Okay, this is called as the blue line is called as your predicted model, predicted values for the your training data. Similarly, we are going to be draw the graph between the testing data, the x test and the y test value. Okay, we are going to draw the graph plot dot scatter plot between the x test and the y test value. Okay, the color equal to y value. Now the plot is nothing but a x test between x test and model dot predict of x test. What means the x test? The test data of the x value. Okay, that is height value. Okay, based on the x test value, we are going to predict the corresponding y predicted value. So you draw the graph between the x test value and the corresponding y predicted value. Okay, now the line of the graph is blue color, and the title of the graph is height versus weight with test data. Now x label is equal to height, y label equal to weight. If you show the graph, it will look like, so that means the line or the model is fit for the our trained data as well as test data perfectly. The two graphs shows that the model, the line or linear regression model is perfectly suitable for the our data set. Now we are going to be draw the graph between the test data as well as predicted data. Okay, so the plot dot scatter plot y test and corresponding predicted value. Okay, we are going to get the look like these points. Okay, these are called as a weight value and actual weight value, called as a predicted weight value. So both now the corresponding coefficient values. Okay, model dot predict x test value that is stored in the we are going to predict the model dot coefficients. Okay, we are going to print the coefficient value. Okay, C value. Okay, and the mean square error. So that means model dot this is okay, model dot predict of x test means predicted value minus actual test value. Okay, mean of that one and square of that one, that is called mean square error. So we are going to find out the mean square error. Okay, that is 143.23. Okay, now suppose we are going to predict the weight value for a unknown value. Suppose in doing that height as a 700 now and get the model. So for the 77, the expected weight value is 243.253. So like that we are going to be predict the corresponding predicted value. Okay, now we are going to draw the relationship. Okay, so here we are having the we are displaying the all the height values and the weight values corresponding to predicted values. Okay, data set. We are going to predict the values. We are going to add a new column that is called as a predicted value. Actually, the data set contains gender value, height value, and weight value. We are going to add one more column that is called as a predicted value. That is, we are inserting the data set within the column. We are giving the name as a predicted value. That creates a new column. So for the new column, the values are model dot predict of x. What is x? X is nothing but a height value. Based on that, we are going to predict the corresponding predicted height weight values. So data set dot height. Okay. Now it displays all the values. Now here these are the actual. This is the original height value corresponding actual weight values one. But our model is predicted as a 219.164. But what is the actual value? 241.89. So that means there is some difference is there between the actual value and predicted value. Okay, this is called as a prediction of your data. Now find the performance of the model based on the different parameters. Like here we are having the one metric is there, that is called as a mean square error. From that, all the metrics, all the performance measures are there in the sklearn dot metrics. From the sklearn dot metrics, we are importing the mean square error. So for the mean square error, we are providing the actual test data and the corresponding predicted value. Okay, then we are going to get the output as a corresponding mean square error value, that is 143.225. Okay, and then like that we are having the predict the mean absolute value. So that is also there in the from sklearn dot metrics. We are importing the mean absolute error value. So mu equal to mean absolute error y underscore test value and y predicted value. So this is called as a actual value and this is called as a predicted value. Just wait now. Okay, now here we are going to get the corresponding mean absolute value, that is the value between the 9.68. Like we are going to find out the other performance metric is R2 square value. So that is also present in the sklearn dot metrics. Okay. From the sklearn dot metrics, we are importing the R2 square value. For this R2 square also we are provide the actual value, comma predicted value. Based on the actual value and the predicted value, we are finding the R square value. We are going to display the R square value. Okay, 0.86. Like that, we are going to estimate the all the performance metrics of the our model. So this is about the linear regression. Okay. So up to now we discussed about the linear regression and how we are going to find out the corresponding performance metrics of the linear regression. Now this is a one more link is there. That is it shows the linear regression documentation. Okay, sklearn-learn.org is there. That organizes provide the entire documentation of the linear regression. Okay, and also there is some blog is there. This blog displays the what are the different types of performance metrics for the what is the difference between the mean absolute value, mean square value, and root mean square value, coefficient of the determination, and adjustment of R square value. Like that, there are different sources are there. You can go through.
Thank you for watching my video. Please subscribe my channel. Thank you.